Hello, this is Ms. DB, and today we are going to finish reviewing Chapter 6, Section 7 on investigating graphs of polynomial functions. And in this video, we're going to focus on mostly on how to graph them using technology, although we are going to also look at what you would do if you had to graph them by hand. We'll do one problem like that. You may want to open up your worksheet and do number 1 along with us when we get to that one, because that's the one you have to do by hand, and it's a few steps, so we'll go through those steps together. And also we're going to learn about maxima and minima of polynomial functions. All right, so we've already learned about factoring, we've learned to solve polynomial equations, we've learned about end behavior, and now we're ready to graph them. So it kind of puts everything together that we've learned in this chapter. Here are the steps for graphing a polynomial function. Find the real zeros and the y-intercept of the function. Plot the x and y-intercepts. Remember, the x-intercept is when y is 0 and the y-intercept is when x is 0. Make a table for several x values that lie between the real zeros to help you plot some points. Plot the points from your table. Determine the end behavior. That's what we learned about in part 1 of this. As x approaches negative infinity, does the graph approach infinity or negative infinity? And as x approaches positive infinity, what does the graph do? And then you're ready to sketch the graph. All right, let's look at those steps with this example. F of x equals x cubed plus 4x squared plus x minus 6. There's a lot of things we know about it already. The first thing we're going to do is we're going to try to find the possible rational roots by using the rational root theorem. And we did this by take your negative 6, that's your p, and your q is 1, and we are going to write all of the possible factors of those. So the possible factors would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are all the factors of, well, really of negative 6. And then we're going to test all of those possible rational zeros until a zero is identified. The easiest way to test these is using synthetic division. So we take our x equals negative 1, and that is what goes here in our box. And then here are our coefficients, 1, 4, 1, and negative 6. Those go right here. Remember, we bring down the 1, and then we use our synthetic division that we've learned about already. So we take 1 times negative 1, and that answer goes right here, negative 1. 1 times negative 1 is negative 1, and you put it here. Then you add 4 plus negative 1 is 3. Then you multiply 3 times negative 1, and that answer is negative 3, and that goes right here. And then we add 1 plus negative 3 is negative 2. Then we multiply negative 2 times negative 1, and negative 2 times negative 1 is a positive 2, and that goes right here. And then we add negative 6 plus 2 is negative 4. That's our remainder. If you have a remainder, then this is not a root. It has to be 0 to be a root. So we tested negative 1. We got that one taken care of. Let's test 1. So we put 1 in the box. We put our coefficients of each term, and then we start doing our synthetic division. So we bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. And then we do 5 times 1 is 5. 1 plus 5 is 6. 6 times 1 is 6. That goes here. Negative 6 plus 6 is 0. We found a root. One of our roots is x equals 1. So we've got one of them. Once you find one of them, you don't have to go through the 2, the 3, and the 6 and the negatives of each of them, because we are going to be able to factor a little bit. If 1 is a factor, that means that part of our, if 1 is a 0, then our factor is x minus 1. So I can break this down into x minus 1. Now, how did they get x squared plus 5x plus 6? Those numbers come from the synthetic division answers. We did this, was this in section 3? So we started with x cubed. So this right here is 1x squared plus 5x, decreasing the power each time, plus 6, and then plus 0 for our remainder. So one of our factors, one of our zeros is 1, so that means we can write this as x minus 1, do the opposite sign, and then these numbers are the coefficients for the rest of it, so x squared plus 5x plus 6. Now look at the x squared plus 5x plus 6. Can you factor that? I think it went a little bit faster than I would have there. So x squared plus 5x plus 6. Look at the factors of 6, which are 2 and 3. Oh, here it is here. It shows up down at the bottom. And that can be factored. This part right here is the x squared plus 5x plus 6 part. So that factored into x plus 2 times x plus 3, and we still had the x minus 1 from what we found our 0 to be. So now we've got it in factored form. This is factored form. Factored form. And you can set each one of those factors equal to 0, x minus 1 equals 0, and add 1 to both sides and get x equal 1. We knew that was a 0. And put x plus 2 equal to 0 and subtract 2 from both sides, and x equals negative 2. That's another answer. That's another 0. And then finally x plus 3 equals 0, so subtract 3 from both sides, and our last 0 would be negative 3. So our zeros are 1, negative 2, and negative 3. Now you also want a few other points. Let's find the x and y intercepts. Well, really, we have the zeros. Those are the x-intercepts. The y-intercept is when x is 0, and that's always going to be the last number, the constant at the end, because this is 0, 0, and 0. So negative 6. So we know that it's going to cross the y-axis at negative 6. And they picked a couple other points. I would not pick a fraction, but they did. And they just plugged them in, and they found the y values at those points. And again, I wouldn't use that 5/2. It's a little crazy looking. But f equals negative 1 is all right. And then they looked at the end behavior. And they saw that because this is, let's see, it's an odd degree, and it's got a positive leading coefficient, odd degree with a positive leading coefficient, odd degree, positive leading coefficient, so it's going to look kind of like this. That's what our graph is going to look kind of like. But it's going to have several x-intercepts, so we know that it's going to actually have some more turning points than that. All right, so now we're ready to sketch our graph. We put on our zeros at negative 3, negative 2, and 1. Put those on. They also knew that the y-intercept was at negative 6, and they had found a couple of other points that they could graph. And then you also know that as x approaches negative infinity, the function is going to approach negative infinity. And as x approaches positive infinity, the y approaches positive infinity. And you would also have to test points, like you'd have to test, oh, that's why they picked such a hard point, because you have to. We need a point between negative 2 and negative 3, and they got that this was 0.875, so they graphed that one. And then I think they did negative 1 and found that that was at negative 4, so they put that point on there. You could also test a point between 0 and 1 if you wanted to. So you've got these points, and then you do your best to grab the pen tool and do a nice curved line between them. That's what you do. All right, now this is number 1 from your worksheet. So you might want to open up. It's a Sketchpad document, so you have to be logged into the Minnows Virtual Student Desktop, and then you open it up. And we are going to go through the steps. Now you'll be answering these on the Sketchpad file. If you'd rather answer them, number 1, in a Word document, you can, or on your own paper. And then the rest of them you'll be doing in Sketchpad. All right, so our first step is to identify the possible rational roots by using the rational root theorem. So this, again, p is 6 again, and q is 1. And the factors, the possible factors of 6 are 1, 2, 3, and 6. Those are the factors of 6, but you also need the opposite signs of each of them. Okay, now we have to test all possible rational zeros until 0 is identified. So just start at, -1 or 1, pick one of the easy ones. And then we're going to use synthetic division again. So we've got, they got an answer of 8. Let's do it a little slower. So you put your -1 here, and then you write the coefficients. So we have 1, then we have a -2 from right here, then a -5, and a 6. And you draw a line a little ways away, and then you drop down the 1. All right, now we start multiplying. 1 times -1 is -1. That answer goes here under the -2. Then we add these together. -2 plus -1 is -3, and we drop that answer down to the bottom. Now we multiply again. We take -3 times -1. -3 times -1 is a +3, and that answer goes right here. And then we add these. -5 plus 3 is -2. Be very careful adding, because that will mess everything up if you get a wrong answer. Then we multiply again. -2 times -1 is a +2. And you write that right here. And then you add. 6 plus 2 is 8. That's our remainder. If our remainder is not 0, then this is not a root. So this one does not work. -1 does not work. Let's check +1. I would just start at -1, +1, -2, +2, and keep going until you find a 0. You won't have to go very long. These problems are set up to be not too hard. So now we have our 1 is already, that's where you put your possible 0, and then here you write your coefficients. So our possible coefficient, or our coefficients of our polynomial are 1, -2, -5, and 6. That's not going to change for any of our test. And then you leave a space and you drop down the 1. And then you start multiplying. 1 times 1 is 1, which goes here. And then you add these. -2 plus 1 is -1. Then we multiply. -1 times 1 is -1. And then we add these together. -5 plus -1 is -6. And then we multiply. -6 times 1 is -6. 6 plus -6 is 0. That means that 1 is a root. That means it crosses the x-axis at 1, which means that x minus 1, the opposite sign, is a factor. And these numbers that we got after we did the synthetic division, these are the coefficients of the rest of it after you factor out the x minus 1. So it was an x cubed, so you decrease that degree by 1, so that's going to be 1x squared minus 1x minus 6 is the rest of it. And now we have to factor x squared minus 1x minus 6. Let's do that on the next page. This is just going to say the same thing. All right, so we had x minus 1, and then we had x squared minus 1x minus 6. We have to factor that. The x minus 1 is factored as far as it's going to go. But this is factorable because the factors of -6 that equals a -1, let's see, that won't work. How about -1 and 6? No, that doesn't work. We want these to add together to get to -1. How about -3 and 2? Yes, if I add -3 plus 2, I would get -1. So my factors are x minus 3, x plus 2. This is my equation in factored form. I factored as far as it can go. And then the next step is to write those zeros. So now that I have, these are my factored forms, so my zeros are, and then you take x minus 1 equal to 0, and you take x minus 3 equals 0, and you take x plus 2 equals 0. And you solve each of these little tiny equations. So x equals 1, x equals 3, and x equals -2. Those are the zeros of our function. That's where it's going to cross the x-axis. In other words, those are the x-intercepts. Now we need some other points. We know that this function, what was this function? +6. So we know that the y-intercept is going to be at 6. So that'll be helpful. And then you're going to pick some points between the zeros. So the zeros again are at 1, -2, and 3. In order to find the other points, take your original function, which was, I should have copied and pasted this, x cubed. I'm going to write this down and then write it on the next page to show you how to find the other values. We're just plugging in for x. We're taking what x is, 2x squared minus 5x plus 6. Okay. Here's our original function, x cubed minus 2x squared minus 5x plus 6. So they're saying, well, first of all, the y-intercept will be 6. That's when x is 0, 0, minus 0, minus 0 is 6. And then to find some other points, you want to take points between the points you already know, these x values that you already know. So let's take one between -2 and 1. Let's do, we already got 0. Let's do -1. So when x is -1, you put in -1 to the third power, minus 2 times -1 to the second power, minus 5 times -1 plus 6. Let's solve this and see what we get. So -1 to the third power is -1. Then we have -2 times -1 squared is +1, so that'd be just -2. And then the -5 times -1 would be +5 plus 6. So -1 minus 2 is -3 plus 5 plus 6. So -3 plus 5 is 2. 2 plus 6, that would be 8. So at -1, the y value of the function would be 8. And then we'll pick a point between 1 and 3. Let's pick x equals 2. And then you'll do the same thing. You'll plug that into the original function. So we'd have 2 cubed minus 2 times 2 squared minus 5 times 2 plus 6. So that'd be 8. 2 cubed is 8 minus, that's 4 times 2, that's 8. Minus 5 times 2 is 10 plus 6. So 8 minus 8 is 0. Minus 10 would be -10 plus 6 is -4. So we have another point at 2, -4. So we have, now we're ready to start. Oh, we look at the end behavior and then we can graph this point, we can put the zeros on, and we'll have a really good idea of what this graph is going to look at. So our next step is to look at the end behavior. We know that it's odd because it was x cubed, and we knew the leading coefficient was positive, so you can look back at that chart from the beginning of this or from part 1 of this worksheet. And we'll see that as x approaches -infinity, p of x approaches -infinity. And as x approaches +infinity, the function will also increase to +infinity. And then we put our, they've already got a graph, but then we put our zeros on. Our zeros were at -2, at 1, and at 3. We knew that the y-intercept was at 6. And then we had found that at x equals -1, it was at 8, and at x equals 2, it was at, was it at -4, I guess? Is that what we got? Yep, that's what we got. At 2 is at -4. So this matches up. So you put all the points on there. This was a point, and this was a point. And then you knew that the end behavior was going to approach -infinity as x approaches infinity, and it would approach +infinity. And then you just take your pen and you do the best you can to go through the points as smoothly as you can, making a curve. All right. So we talked about turning points already, but that's where a graph changes from increasing to decreasing or decreasing to increasing. And every time there's a turning point, you get a local max or minimum. That means that it's the highest point around it or the lowest point around it. All right, so it will always have one less than the degree. That's how many turning points it'll have. At most, it can have less than that. And we can graph these to figure out what our local max and local min would be. All right, so we are going to use Sketchpad to graph these, but here's an example of what it would look like on your graphing calculator. So you type that in, and you graph. and you can see where the zeros are. You can see that there is it's not the maximum because it's going to increase forever as you go to the infinity, but there's a local maximum right here at this turning point, and there's a local minimum right here at this turning point. And what you do is you put a point there, and then you can zoom in, or you can do trace and get your point to move to about there, and you can read the numbers at the bottom of your screen. In Sketchpad, you can click on that point and then measure. And they're just finding the minimum here. Minima. All right, so let's look at what we're going to do in Sketchpad. I've got it open here. Move this over. And number 1 is the one that we went through. This is the same. There's an example over here. And it's got the steps. And then the one that you're going to do is the same as the one that we just went through. So hopefully you were jotting it down. All right, let's look at graphing using the Sketchpad tools. So we're going to graph p of x equals x cubed plus 6x squared plus 5x minus 12. And this is actually the exact same graph from number 1, the one we just did, but we're going to use technology this time. So you'd go to graph, plot new function, and we're going to type in everything after the equal sign. So for the cubed, you use this little button here. So x cubed plus 6x squared. And for squared, you use that again. Plus 5x. You can also use Desmos if you prefer for this. And then we hit OK, and there's our graph. And you can see that our graph has the zeros that we thought it would. Let's grab a point tool and put those on. Our zeros we had at, actually, that looks like -4. Weren't our zeros at -3 and -2? This must not be the exact, oh, I changed. This is not the same as number 1. I changed number 1 to match the one that was in the PowerPoint that I was using. So this is not going to match the graph for number 1. This one's zeros are at -4, -3, and 1. All right, let's see what we need to answer now. So this would be, no, it's not the same graph because I changed it. All right, and then you're going to answer some questions about it. This one you just have to graph, but on some of the other problems you'll be answering what is the local maximum and local min. So in this one, the local maxima would be right about here. So you can go to measure coordinates, and you can find that the local maxima is at approximately 1.12, the y value of that. And here's the coordinate of that point. And let's do one for the local minima, which is at about right there. And again, we can go to measure the coordinates of that point and find the approximate local minima of this coordinate. And again, the zeros are there. We could measure those too if you wanted to. Measure and see if we really got the zeros there. I must have had something. Can't I measure all of them at once? Yes. Yep, I did put them at the right zeros, so those would be the zeros. The y-intercept of this one, you could find that from the graph too, is at -12, which matches the -12 at the end of the function. That will always be the y-intercept. So you're going to go through these other ones, and you'll graph the function, just like we just did, and estimate the maximum and minimum values. I wrote maximum and minimum rather than maxima and minima. These are the local ones, though, not the max of the whole thing. So I should have clarified that. And you'll just continue through using your technology, finding the values of the local max and local min. And that's about all you have to do. So let me know if you have any questions. This shouldn't be too hard using your technology, and have a wonderful day. Thank you.